Prelims 2013 question from climatology. And the question reads, the annual range of temperature in the interior of the continents is high as compared to coastal areas. What are the reasons? So this is a concept based question taken directly from the idea that we identify as maritime effect versus continentality. So what do we mean by these terms? First, when I talk about the maritime effect means the temperature in the coastal areas never reaches extremes, which means the range of temperature. So range of temperature here is low. The temperature never reaches extremes. Whereas in the continentality, the idea is in the interiors of the land, the temperature reaches extremes. Okay, where the range of temperature would be very high. You can think of this comparing the climate of Mumbai with that of Delhi. So Mumbai's annual range of temperature would be very low. Whereas in case of Delhi, because the interiors of the land are there, therefore the winters would be very cold, the summers would be very hot, the range of temperature is very high. So why is it so? This was precisely the question. Now the idea is about the land-water differential or the thermal differential of land and water. Now what is this thermal differential of land and water? Okay, here the statement we can put is water is heated or cooled slower than land. So water being heated slower than land or cooled slower than land, what are the reasons? Let's try to understand. So the first reason with respect to heating or cooling of any object, okay, would be related to something called as a specific heat of the body. Now, a specific heat of the body, what do we mean by specific heat? So a specific heat of any body would mean the amount of heat required to raise the temperature of unit mass of substance by 1 degree Celsius, which means the specific heat is the amount of heat that you will need to heat the object. So very obviously, if a specific heat is high, which means you will have to provide more heat, and so the heating would be slower, so slow heating. So if the specific heat is lower, then you will have to supply lower amount of heat and the substance temperature would increase, which means faster heating. So in this case, if we talk about land and water, what we see is the intrinsic property of water, that is water has high specific heat. So when the specific heat of water is high, we can say that the water is going to heat slowly. Along with that, another property of water, if we see, so if I have to compare over here land with water, so over here land and water. So in this case, what is going to happen when the sun rays fall on these two? Let's say the amount of insolation is same in these two cases, yet over here what we will see is in the water the sunlight would be able to penetrate more, and the extent up to which the sunlight can penetrate in water, okay, that is what we call as photic zone, which on an average reaches up to a depth of 200 meters. So in this case we can say that water is transparent to solar radiation. On the other hand, in case of land, it is going to penetrate only up to few meters, that's it, not more than that. So in these two cases, if you see, because the sun rays are penetrating more into the water, the same amount of heat is distributed over large volume. Whereas in this case, the same amount of heat is distributed over lesser volume. So in this case, which is going to heat faster? Very obviously, land is going to heat faster. In this case, because the volume concerned is very large, therefore the heating is going to be slow. So the second reason that I see over here with respect to water being heated or cooled slower is where I can say the water is transparent to solar radiations. So transparent to solar radiation. This is the second reason. And along with that, third reason, if we see, now in case of water, what is going to happen, that water molecules can move. It's a fluid. So water molecules can move. As the water molecules are free to move, what is going to happen is there would be constant movement of the water, as a result, constant intermixing of warm and cold waters. But because there is constant intermixing of warm and cold waters, okay, it's like a bucket you are filling with hot and cold water tap both opened simultaneously. Okay, at any point of time, the temperature of water in the bucket would not be very high. That's the same idea, wherein because of constant intermixing of warm and cold waters, the temperature does not rise abruptly. Whereas in the case of land, what is going to happen? The molecules are not going to move anywhere. So the molecules which are exposed to the sunlight, okay, they are going to remain exposed to the sunlight, and that is where the heating would be very rapid. So over here, the third reason would be intermixing. So intermixing of warm and cold waters. Due to these three reasons majorly, okay, the rate of heating or rate of cooling of water is slow. In fact, very slow compared to land. And therefore, the temperatures of the waters never reaches extremes. So very obviously, the coastal areas temperature also will never reach extremes. So this is majorly the maritime effect is because of this thermal difference between land and water. This is the whole of the idea of what we call as land-water differential and the resultant maritime effect versus continentality. So now coming back to the question, what is the question reading? Question is very straightforward. Okay, it asks why and reasons. If you see thermal difference between land and water, we know, yes, this is correct. This is what we have just now learned. Second, variation in the altitude between continents and oceans. There is no rule regarding that. Okay, when you are talking about ocean and continents, okay, coastal areas would be at the sea level only. And so the altitude of ocean as well as continent in the coastal areas would be similar almost. So then in that case, this factually itself is incorrect statement. Third is presence of strong winds in the interiors. This again may or may not be true. It cannot be a rule. Okay, because when we see as a statement itself, okay, we know about the planetary winds. Planetary winds, westerlies are strongest of the winds. So that also, okay, over the oceans, southern hemisphere westerlies are strongest. Okay, in fact, water provides less friction to the winds, and so winds are in fact faster over the water. So in that case, this statement itself is incorrect. Forget about whether it is a cause or not. And fourth, heavy rains in the interiors as compared to the coast. This again cannot be a thumb rule. So, and anyways, if there is heavy rain in the interiors, then the temperature cannot rise abruptly or so. Range of temperature would not be that high. So in this case, I find that all these three statements are incorrect. So my answer becomes A, that is 1 only. So to this question about maritime versus continentality, the answer is thermal difference between land and water, which causes higher contrasts in temperature or higher range of temperature in the interiors of the continents.